I think you were late yesterday, so that's why I said I didn't see you. Hey, Kaylee. Good morning. So, let me get you guys started on this. This is our last chance to see if we get 80% or better on the quizzes. 80% is what we're looking for as far as to see if this gaming really helps us. So please get in there and try these out. Good morning. So that says, hey, wait up for me. Good morning, Gabby. Hey, Kylie. Good morning. Good morning. So if you guys will get in there, first name, last initial, last time for the 10 questions before we take the post test. Hey, Ken. Hi, Isaiah. Let's see who else we have in here. Good to see you. And we've got Madison, and we've got Natalia. Revi, where have you been? I have not seen you. Morning, Jaden. Where's been Revi's been? I haven't seen you in a while, Revi. Have you been okay? Been okay? I'm gonna change the settings here. All right, I'm making me an account. Okay, thanks, Kaylee. Thanks, Rachel. Just one person in there, so as many people as possible. Just want to see if you can get that 80% or better. 80%. Come on, DeAndre. Let's get in there. Devin, Chloe, get 100%. I got some 100% last hour. Not many. Most people it's 70%. So getting in there. Natalia. All right. Get in there. Get in there. Savannah, get in there. Raker, you're gonna get 100% on this. Come on. Get your 100%, get your 80% or better. Come on, Danny. Come on, Dalton. All right. We're gonna get started because we were already started about 5 minutes here. So you can get in there, that link here. Let me clear the chat. You can come in late, but I'm gonna do that. Okay, let's start it off. See how this goes. This is bonus points. It tells me if you're doing the practice. So we got Chloe. Thanks, Chloe. And we got Gabby. Thanks, Gabby. We got Kaylee. And we got Madison. Thanks, Madison. We got Loader. Come on, guys, get some in there. Oh. Won't let you. It should. So shouldn't it just go straight in there? I think if I why that isn't the case. Should be go right. It never has me put in the code. Hey, thanks, Danny. Thanks, Ken. Look at that. We got 3 10 out of 10s. Excellent. Try to get that 80%. Okay, so I'm going to let you guys finish up here. I'm going to click on a new link for you guys. And let me go ahead and let you guys finish that. I'm going to turn the sound off. Come on, stop. Stop. Why are you doing that to me? There we go. Okay, there we go. All right, so we're going to do this Nearpod assignment here. Okay, start a new session here. So we're going to go, instead of Pear Deck, we're going to do Nearpod today. Because I've got a couple videos to show you. Let's see, here we go. Copy link. All right. Here is the Nearpod assignment. All right, so let me all right, so we got go this one here. We're done. Oh, good job. We got 100, 180, 80, 60, 50, and 20. So it's a little work on some people, but it could be, like you said, misclicked or something, right? Okay. All right. So I'm going to show you this video here, and hopefully you can hear this. All right. So this is what we talked about yesterday, hydrogen bonding. Surface tension is because of hydrogen bonding. So this is what we used to do experiments in science class. Take a penny and an eyedropper and see how many drops of water we can put on a penny. Because the hydrogen bonding, this is the intermolecular forces, the inter, because that's between molecules. People get that mixed up. Between molecules, there's more than one molecule. You got that H2O, right? H2O, and then another H2O, right? And then the oxygen wants to bond with the other water molecule. And because that does that, right? There's another oxygen and another molecule. And then because it does that is why we get this surface tension. The person is shaking the table. You can see that it's holding together there. And we used to have a competition to see how many you could get on there without spilling. And usually it was like 20. We could get like 20 drops. And there we go. All right. So let's take a look at this one here. Okay. So do me a favor here. Tell me which one of these. So this one says intermolecular hydrogen bonding occurs between two neighboring molecules. It's between, and then intramolecular hydrogen bonding occurs within a molecule itself. All right. So tell me which one of those. So match them for me, would you please? Match them for me. Okay. All right, so let's match those. Okay, see who we have in class here. Got 10 people. Fantastic. Okay, so let me see. All right, so we're matching. Good job. Yes, intermolecular is where you see a bunch of molecules. Intra, good job. Thanks, DeAndre. Good job, DeAndre. All right, DeAndre, thank you. See who else we got here. Yep. And we got Danny. Thanks, Danny. So that's what you should be getting there. Thanks, Danny, for getting in there. Yep, same thing here. Dylan. Thanks, Dylan. So inter and then intra. That's the one that, again, that's why I give you the notes, right? That's why I give you the notes so that you can figure out how to do this. Thanks, Gabby. And let's see if we got anybody else. Still waiting on Ken, Kylie, Loader. All right, Loader, you got it. Yep, that's it. Intra is in the molecule itself. There's no other molecules around it. Yep, you got it, Madison. Thanks so much. Rachel, yep, you got it too. Right. And who else? That's it. Okay. Okay. So just the idea between those two. So now we're talking metallic bonding. As if we didn't make it hard enough, now we've got to talk about metallic bonding. We just talked about hydrogen bonding. Now we're talking about metallic bonding. The bond between metals, okay, metal and metal. So far we've talked about hydrogen attaching to other molecules, right? The hydrogen bonding. And now we're talking about metals and metals. So we had ionic, which was non-metal and metal, or metal and non-metal. We had covalent, which is non-metal, non-metal. And then we had different varieties of covalent, which was hydrogen bonds, right? But then they had this strange electronegativity of oxygen that created these hydrogen bonds and nitrogen. So now we're going to talk about the metallic bonds. I can define metallic bonding and how electrons move freely between the mines, the mines to create metallic bonds. I don't know where I put mines in there for. Okay, so we're going to watch this video. Okay, and let me get you guys started here. Tell me if you can hear this. All right, so this, you're also going to have, oops, I got to start all over again. You're also going to have poll questions as we go too. All right.
Metals are used in many everyday objects. This morning, when I woke up, I decided to have a soft-boiled egg and a cup of coffee. The pot I used is made of metal. The kettle is made of plastic, but the coiled heating element inside it is made of metal. Metals are good conductors of heat. This is the reason why metals are used to make these everyday objects. You would never see a pot made of wood or a heating element made of plastic. Metals are also good conductors of electricity. The wire connecting your
Okay. So what is meant by a conductor? Okay, so let's take a look at this as a poll question. Start a poll. Here we go. So if you are in Nearpod, don't worry about voting on the poll. Okay. All right. So if you're not in Nearpod, you have a chance to vote. Is it the materials have non-metals? Material does not allow electricity to flow, or is it C, material does not allow electricity to flow through it, or B, material does allow electricity to flow through it. So A, B, or C. Okay, thanks, Mackenzie, Kaylee, Dalton, Devin, Bryce, Chloe. Anybody else says it's not? Isaiah, if you can get in there. Grace, if you're not in the assignment, Nearpod, or Christian, Bam. I don't see Bam getting any there. Madeline, and Devin. All right, let's publish the poll. We got 9. Okay. And most people said it was B, material that allows electricity to flow. And that's what was true on this one as well, material that lets things to flow.
your kettle to the electrical socket is actually made of many copper wires, insulated with a layer of rubber. Think about the shapes of the everyday objects we described: the pot, the heating element inside the kettle, and the copper wires. Notice that they are very different. Metals are malleable. This means that they can be molded into different shapes. Metals are very ductile. This means that they can be stretched into wire.
Okay, so what does malleable mean? What does malleable mean? So let's put that in a poll question here. What does malleable mean? Okay, start a poll. What does malleable mean? All right, does it mean rigid and firm, easy to break, can be bent or molded into different shapes, can conduct electricity? What do you think? Come on, Bam, Bryce, Christian, Devin, Emily, Bella, Isaiah, Jaden, Jasmine, Devin, Madeline, Michaela. Thanks, Isaiah. All right. So we have, most people are saying it's letter C. And that's true, can be bent or molded into different shapes. Excellent.
Wires.
So what does ductile mean? What does ductile mean? So, and we've talked about this a long time ago, so it's probably something that you have remembered hearing, but again, what does it mean? What does ductile mean? Start a poll. Does it mean can be stretched into wire, atoms line up, can be broken easily, is made of nonmetals? All right, so that's 7 out of 34. We got a lot of people here today. A lot of people. And a lot of people sitting in the background. Hey, Michaela, Paris, kind of getting there. Savannah, Riker, if you're not in the, and Shine, Savannah, yeah, go ahead, guys, get in there. Yeah, 11 out of 34 says A, can be stretched into wire. Excellent, excellent. And same way here,
To
stretched
fully
into wire.
understand these properties of metals, we must understand metallic bonding. When we talk about metallic bonding, we are actually describing the electrostatic attraction between the metal ions arranged in a lattice structure and the free-floating electrons around them. Since these electrons are free to move around, the term sea of electrons is also used.
All right, sea of electrons. What does sea of electrons mean? Let's see, let's do this. What does can we do this? Okay, there we go. What does sea of electrons mean? Electrons are free to move around the atoms. That's A. B. Electrons are bonded between atoms. C. Electrons are trapped in place. All right. Come on, Stephen, Sophia, Shine. Come on, Paris. All right. So most people got 9 people again. Thanks to those 9. Did Isaiah, you get in there too? Isaiah is voting, right? Thanks, guys. 11 people. Okay, so it is. Electrons are free to move around the atom. Remember, this is metal to metal, right? It's not non-metal or anything. It's not an ionic bond. It's a metallic bond we're talking about. So,
What is a lattice structure, and where have you heard this term before? Let's pause the lesson to think about this and resume when you are done. The term lattice structure means that there is a regular repeating pattern. We have heard this term before when discussing ionic lattices.
okay. So what is the structure of lattice structures? A random pattern of atoms when metals and nonmetals bind. Metal atoms are arranged side by side in repeating pattern. It is another way to say covalent bonding. All right, you guys are getting it. Thanks, ladies and gentlemen. Thanks, Isaiah. All right, so we got 10 again, almost 11. Here we go, 11 people. And most people said C, metals that are arranged side by side in repeating pattern. Exactly, exactly. You guys are great.
These. It is used to describe the alternating positions of the metal and nonmetal ions. In metallic structures, however, there are only metal ions. These metal ions are arranged side by side in a regular repeating pattern. The free-floating electrons act like a glue and hold the structure in place. This is a very strong attraction and explains why metals have high melting and boiling points. A lot of heat energy is needed to overcome this attraction. This is also why metals are very good conductors of heat. Free-floating electrons are the reason why metals can conduct electricity. Metals are malleable and
All right, so why can metals conduct electricity? Let's do that poll question. Start a poll. Is it because the electrons do not move, because they are in ionic bonds, because they are covalently bond, because they have free floating electrons? All right, so most of you guys have gotten it. It looks like people have, because metals are not covalently bonded, right? They are bonded by metal and metal. So let's publish this poll. We got 8 people here. So this is saying that because they're free floating electrons. So metals and metals, free floating
ductile
electrons.
because no matter what shape the metal takes, the free-floating electrons will conform to that shape. The strong electrostatic attraction will remain, and therefore the structure stays intact. Let's think about it. Cars and bicycles, trains, planes, buildings, cutlery, spectacles, furniture, and endless items can be made from metals. To recap, the electrostatic attraction between metal ions arranged in a lattice structure and free-floating electrons is known as metallic bonding. This
Okay. So bonding between metals. Okay, so both metals lose electrons to become positive ions. So here's this a picture here, right? So this is a metallic bond. So if you see a picture like this where the electrons are just going all over the place, this is a metallic bond. All the positive charges of the positive ions of the metals are the same, and the electrons move around and vibrate. Okay, the electrons move freely, and it's a very strong bond, right? So they call this um, bonding delocalized electrons. Okay, so delocalized means not local. So that means that if you were a homebody, you would be staying next to your positive ion because you are attracted to the positive ion, but you are unattached. So that means you can go anywhere, like a sea. So they usually call this a sea or a cloud. Metallic bonding can be thought of as a cloud of positively charged ions immersed in a cloud of valence electrons. Remember, valence electrons are the outermost shell, and those are the ones that do the bonding. So it's not the inner ones, it's always the outer ones. So so if you can think about this, they can go through this maze, they can go anywhere they want, but because the positive charges around them, they can only go, they can't leave, but that makes them very good conductors of electricity and heat, makes them very good at, you can pound them into shapes. So electrons, metals are conductors. Why? Because electrons are closer together to bump into each other to transfer heat. So remember the metals are in purple here, and those all are high melting points, um, and there are quite a few of them, quite a few of them. So properties of metals, They're malleable, can be pounded into shapes, ductile, can be drawn into wires. Why? Because electrons slide past each other, allowing it to be easily hammered or stretched. Electronics, copper. Electrons allow the positive metal ions to slide across each other to be stretched into wire. So those are good things. All right, so allow for high boiling point and melting point. So here you see a picture of a hammer, industrial hammer that smashes metal with great force. It's why electrons are closer and strongly attracted to each other, and the positive ion from this law of opposites attract. Remember, positives attract negatives. Okay, so we are done right here. So if you're in the um, you're in the Nearpod, there's a link right there. I will get you this link here in a second. Here, I got to get it for everybody. 4 questions. See how you're doing. Then what I'm going to do is I'm going to do a breakout room for. Okay, let's get this real quick. I'm going to do a breakout room for people that didn't do well or didn't do the exit quiz yesterday on, and we're going to try that over again. So the exit quiz from yesterday, where, let me clear this out so this is better. So here's your 4 questions on the Google Doc, Google form. So I'm going to look at the yesterday's quiz, and then I'm going to ask people to come into breakout, and we're going to go over the exit quiz from yesterday on hydrogen bonding. All right, so go ahead and get on to that. So you have choices today. So if we go to courses, all right, let's go here. You have in your course today, while you're doing that, you have in the modules, week 13, you've got graphic organizers. So the graphic organizer includes the assignment 2, what talks about metallic bonds. Okay, so you can use that. Somebody came to me last hour and asked me some questions about an assignment, and I said, did you use the graphic organizer? And they go, where's the graphic organizer? It's like, okay, graphic organizer is in the module. All right, so you should have done W13 assignment 1 yesterday. All right, using the graphic organizer. All right, today what you want to do is using the graphic organizer, you want to do W13 assignment 2. Okay, so you have time to do that today. You got about 30 minutes left, 25 minutes left, so you can do that. And if there's only like 7 questions in there, and you got 99 attempts, and then you have a choice. You have a metallic bond. You can 8-point bonus points for this. Tell me if this works for you, though. I think that people were having trouble. So this one is bonus Ed puzzle metal metallic bonds. Okay. All right. So this one is that. So you got that to do. You got a couple of those. All right. So I'm going to stop the video here, and then I'm going to start pulling people into. Okay, so I opened up a breakout room. I invited a lot of people. Either they didn't do the exit quiz yesterday, or they weren't here yesterday, or had a low grade. So please get in, and we'll go over those assignments. Shouldn't take more than 5 or 6 minutes, and then you can get full points for the exit quiz.